Hello and welcome to the Immunological Reviews podcast. My name is Justina Studanlik, and it's my pleasure to be here today at the Cancer Research UK London Research Institute with Facundo Batista, who is a group leader here at the Lymphocyte Interaction Laboratory. He is an internationally renowned immunologist who studies B-cell activation at the molecular and cellular level. In addition, he is the guest editor of Volume 251 of Immunological Reviews, covering cell-to-cell contacts, along with Dr. Mike Dustin from NYU. Facundo, welcome.
I would like to thank you, Justina, for crossing the Atlantic and for this interview. And also I would like to thank the editor Gary Koretsky to give me this opportunity.
Can you give us a brief overview of your scientific backgrounds, about your journey from Argentina to Italy to the UK?
My story, that it may be a little unusual because, yes, as you say, I was born in Argentina, where I did my university studies. But then for a PhD, I planned something different, and similar to many of my colleague students at that time, I decided to go abroad. But I then felt that I was prepared to go to the US at that time, and this opportunity of doing my PhD in Italy came along, and I took it. And it was a rather funny situation because I went out with an open ticket, and I never used the way back, actually. So if I would have not gone there, I would have simply traveled to Europe for a year and come back. And then I was very much inspired by the only Nobel Prize in immunology we have, Cesar Milstein, and I went to the laboratory of molecular biology in Cambridge to do a postdoc in the laboratory of Michael Neuberger. And I have the great opportunity of sharing at least the floor with Cesar Milstein over the last few years that he was there. So for me it was very, very inspiring having that opportunity. And as you say, actually, thanks to the studies that I did together with Michael Neuberger, I joined the Institute about 10 years ago already. In fact, it's probably the time to do a 10-year retrieval with all the people that were in the lab. And here I am today, actually, 10, 11 years after they joined this institute.
Thank you, Facundo. Could you also tell us about how you came to know Mike Dustin?
I admire the work of Mike for quite a long time. And in fact, he was very inspiring, his work, and Mark Davis and many others in the field, that they were initiating imaging studies. So actually, Mike may not remember this, or maybe he does, but the first call I did when I joined the institute to set up my lab was to Mike Dustin. So I was given here a computer and a telephone, and I felt that I really want to initiate or try to apply the technology Mike has developed to try to address some questions regarding B-cell activation. And in 2002, actually, when I started my lab, I asked Mike whether I could visit his lab for a short stay. And in fact, he agreed, and that relation has developed over the years. We did a couple of work together, collaborations, and I have the opportunity to share him with meetings and discussions after that.
So can you tell us about what technologies you relied upon when you began your studies in cellular immunology, and how these have evolved over time?
That is an interesting question, because I think the whole field of immunology and signaling has been transformed, in my view, for imaging. And over the last 15 years, I mean, we can now see things that we couldn't see before. And in fact, when I joined the institute, my big request at that time was to have a confocal microscope that I can use in order to develop, to establish the artificial lipid bilayers that I have learned to use in the laboratory of Mike Dustin. But since then, actually, imaging has done a lot, not only in terms of just using artificial bilayers, but in terms of using total internal reflection microscopy, in being able to see single particles of receptors moving on the surface of cells, and even, as we highlight in the issue that we are publishing, seeing how cells get activated in vivo, or where and how or with which other cells do they interact. So I think imaging has grew immensely, and still there are a lot of things that we need to acquire in order to fully understand how lymphocytes are activated.
Could we talk a little bit about the discovery of the immunological synapse and the view of its role in activation?
Well, I think in my view, I mean, the discovery of this dramatic organization that happened of receptors while T cells and B cells, and now we know it applies to NKT T or CD8s, are activated. It is fundamental. I mean, and it's fundamental because it shows that activation of lymphocytes is not simply being about cross-linking or engaging a receptor, but is about the whole dramatic organization of the cell surface of the cell in order to discriminate between whether getting activated or not. And the formation of the synapse is something that correlates in many cases with activation. And I think that it's just the tip of the iceberg to understand really what is going on. I know that there are arguments regarding, well, we can also activate T cells with anti-CD3s or B cells with anti-BCR, but I personally do not believe for a second that is the way that is happening in vivo. And I mean, now by getting resolution and by getting the right tools, we can start to see that synapses and synapses are formed in vivo. And it is about actually the organization of receptors, and it's about the dynamics of this organization and the exclusion of phosphatases and the timings of recruitments, that it will give us real insights into how lymphocytes are getting activated. So in my view, the discovery was transforming, and I mean, we were used to activate lymphocytes just cross-linking receptors. And as the issue illustrates, I think that it's all about cell-to-cell interaction. And when two cells are interacting, it's not the same that just engaging a receptor on the surface of a cell. So I think that there is a lot to be worked and a lot to understood. And it is probably not enough to understand everything in the context of TCR and BCR, but it may apply, like we are starting to see, in other molecules of the immunosystem, such as lectins or other receptors. So we are talking about general receptor reorganization of the cells and signal transduction, and that is the big difference.
So Facundo, can you tell us about the studies that are ongoing in your laboratory?
Yeah, I think that it's a little like this issue actually, right? What my lab is particularly interested in is in trying to understand how B cells are alive, and that is why we are paying right now particular attention in tonic signaling. That is a signaling that happens in the absence of BCR ligand interaction and keep B cells alive. But also we are interested to understand how B cells do get activated. And in this regards, we go very similar to this issue from single molecules, try to understand dynamics of receptors into in vivo imaging, and linking that together with studies where we characterize the fate of cells during differentiation. So we keep a close eye and try to develop imaging technology around the questions we are addressing and try to see what question can be addressed in one way or the other. And in the moment we are particularly interested about the super resolution microscopy. I mean, we are showing for the first time that receptors are aggregated in BCR, similar to what has been suggested for the TCR, are aggregated in nanoclusters, and these nanoclusters are very similar to what Mark Davis has described, organized in islands. And these islands are constituted in the molecular, again, in what we like to call the molecular landscape of receptors. And we have, like, the BCR is in a certain islands, and C19 are in equivalent islands, but whenever they're activated, they are coming together, and this is key in order to allow the B-cell receptor to deliver signals. So although, again, this is a very reductionist approach, as we have been following, we believe that combining this with genetics is very important to try to understand what are the key initial events that are driving B-cell activation and what are keeping B-cells alive.
So can you tell us about how the imaging technologies have specifically affected the questions that you have asked in your work?
Well, I mean, in many cases they are illuminating the path along, but at the same time they are limiting what we can see and what we can get, actually. For instance, when we were using initial studies by using confocal microscopy and using artificial bilayers, we could see cells that are interacting there, but we were lacking the resolution to see how signaling molecules were recruited there, for instance. And now, thanks to the work of Takashi Saito and Mike Dustin again, that they have introduced TERF microscopy, and my group did something also in that direction, actually. We can now imagine how these molecules can assemble into microclusters, actually, that they were impossible to see in 5-10 years ago. And now with the super resolution coming into action, actually, we can understand how many of these molecules are in each microcluster and how these proteins are arranged into what I like to define like the molecular landscape of cells, of which we really understand very, very little. Because also we are limited by the time at the moment because we can see only one or two or three of these players, but we know what the receptors are in thousands of subsets of cells. So what is the landscape that they have, how they are organized, where they are in nanoclusters, that is referred in one of the reviews that we are discussing, and what happens with those nanoclusters or oligomers when the cells are activated. I think that those are very important questions that are going to be answered in the next few years.
So what can you imagine would be some technology that would really allow your studies to push forward?
Good question. Because at the moment, although imaging can show us many things, it still doesn't show us the full picture. And in fact, for example, studies that we are performing right now, we and others actually in terms of super resolution, that allow us now to position receptors at really nanometer scale. You need to imagine that cells, for instance, are in the order of microns. And confocal microscopes allow us to see like 1 micron section of the cells. But what microscopy allows us to do now is to really position single molecules of receptors. And in fact, there is a couple of reviews in the issue we are publishing that relates to that. But at the same time, what we will need to do in the future is try to image or to develop this dynamically in a way that now we can see different receptors at the same time at a super resolution level. But also another aspect of this will be the one in which we can follow lymphocyte activation in vivo too. And in that respect, it's not only imaging that is going to be evolved, but also we need to build the right genetic models to study this, to be able to trace us when they have activated in vivo, and to see what happened to them after, and to be able to image them, to understand the location and the place and what is the fate that they will follow after.
So in this volume of Immunological Reviews, there are 14 outstanding different reviews from many laboratories. Can you give us an overview of just the general themes that are covered?
I would like to start to thank also Gary, because he actually came along in a nice meeting that he organized in Siena, and he, with the idea of organizing an issue on cell-to-cell interaction. So he came to me and Mike Dustin and said, look, what do you think about this idea? And we both felt that it was a very important question, because again, what imaging has done in the field is to make us understand that cells are not living in isolation. And in fact, cells are all the time interacting to each other. So the idea that the fate and the activation or the homeostatic behavior of cells are determined by cell-to-cell interaction is central to understand how the immunological response works. And in this particular issue, we have taken the theme actually of cell-to-cell interactions, but we have also focused in novel aspects of in vivo imaging. Therefore, there are one review looking into lung imaging or lymphocyte or lymph node imaging, another looking into bone marrow and how B cells are able to, plasma cells in particular, are able to live in bone marrow by Claudia Berek. And essentially we have taken also, from the in vivo, we have gone down into the molecular level, and we have in a couple of reviews looking into what is the organization of receptors at the cellular level, and what happens with that organization of receptors when the cells are activated. And I would like also to take this opportunity to thank to all the authors of the issue, because they have put a tremendous effort not only in setting up the reviews, but also to keep them in the tight schedule that we have done, and also for the fact that most of all the people that are in this review actually are leaders in the field of expertise. So they don't only write this review, but also they have published probably the most relevant studies in the topics that we are touching right now. So what I feel is that really we have the view of the experts in this case, and I think with these 14 reviews we are able to illustrate the whole issue, or the main ideas that are around, and the topical ideas that are around right now in cell-to-cell interaction.
Well, thank you very much. It's really been a pleasure speaking with you, and it's great to meet you and to be here in the UK.
Thank you for Gary, for this opportunity, and thanks to Mike Dustin, actually, with whom we have been editing this issue for you. Thank you very much.